Good afternoon, everybody. The title of my presentation have the title Synthesis and Characterization of Particles Impregnated by Dithizone with Potential Response Optical. I am Rodrigo Javier Jesus and start the introduction. Nowadays, heavy metals are a big environmental problem for the contamination of water for open dumps and industrial waste. Heavy metals bioaccumulate in the human body. For the human body, don't have a, a way to eliminate the heavy metals in the body. This presents diverse diseases that involved or developed through technologies for detect heavy metals. Between these optical sensors have a great potential to use for environmental diagnostic, agricultural and industrial monitoring. These have a lot of advantages like stability, fast response, effectiveness, and relation cost benefits. The optical sensor validates with the support an optical indicator using dithizone as an optical indicator and support is a nanoparticle MSM41. In this study, we propose the synthesis of polymer particles made with solar technique and adding an optical indicator in the nanoparticles using different techniques to characterizations like FTIR, TGA SEM. It will make an evaluation like colorimetric sensor with those analyses obtained that surfactant of nanoparticle is the main cause of change color in the powder, responding in presence of copper and the aqueous solution. In the methodology, we have CTAF, TEOS, ethanol, and water. These combinate 80, 80 degrees in steaming and heat for two hours. So it's filtrated the content and dry in vacuum. Vacuum with heat to 100 degrees. So the nanoparticles obtained in the first step was suspended and adding the dithizone solution in solvent. In heat and steaming for 1 hour and the solution obtained filtrated and dry. In the vessels, we have obtained the powder white like in the literature. This powder presents the dithizone impregnate and change the color orange. The equal we have uh, 3850 a wave number, a percent of methylene of the surfactant indicate the presence of the surfactant in the nanoparticles. With these nanoparticles without the calcinate. Equivalent thermograms in the eye, not in image material calcinate, the mass loss is about 10%. A difference to MSM41 functionalized with TGA and impregnated with dithizone, the mass loss is about 40%. So the nanoparticles with the same presence is not spherical form. The morphology is not spherical and the irregular distribution. In the same have present the honeycomb form. For the honeycomb like the literature person. Equal with colorimeter, testing the change of color in the powder. The powder orange have a coordinate of FTIR, and the powder impregnate with dithizone and in solution aqueous of copper, obtaining a change of color to brown. We have the limited detection to minimum concentration to the sensor colorimetric detect the copper. We have the minimum concentration is the where 55 per ppm, and in pH response, the nanoparticles appear with this in a solution of copper. The pH optimum for work is the pH 5. And in conclusion, the nanoparticle in semiconductor is a powder white that the test mentioned, and the color change when impregnated with dithizone are orange possibility a percent of superfan cited in the sample. Use a nanoparticle in the semiconductor impregnated with dithizone for present advantage and synthesis and response with copper in aqueous solution. Being confirmed the added nanoparticles with dithizone using diversion techniques FTIR, TGA SEM, and SEM. In copper, the colorimetric sensors has a response positive. The low concentration, the minimum the copper is a 5 ppm, and pH optimal to detect was pH 5. The total hard quality data put the hard limits to use, and it's all. And the acknowledgement to conacid for acquisition the materials and reagents, and conacid for el scholarship masters CLU 108999. Thank you.